Okay, in section 5.3 we're going to look at a couple of other identities. The ones we're going to look at today are what we call the sum or difference formulas for cosine, sine, and also tangent. The general formula is here. The cosine of any two angles added together or subtracted from each other is always going to be equal to the cosine of the first times the cosine of the second, and then either plus or minus the sine of the second times, or sine of the first times the sine of the second. The key issue here with cosine is that there is a sign switch in either case. So in other words, if I want cosine of u plus b, that's equal to cosine u cosine b minus sine u sine b. And vice versa, if I had u minus b for cosine, it would be cosine u cosine b plus sine u sine b. Now, besides being identities, which these two are, okay, we can use them for a couple of different things, which we'll see right now. So the first one is we want to find the exact value of cosine of 75 without using our calculator. Now we know that 75 is not one of our nice angles. It's not a 30, 60, or 45, or any relationship, or have a relationship to any of those. So what we're going to do instead is just try to figure out, and this is the key element, is can we figure out a set of angles that either add or subtract to give us 75, and that are both nice angles for us. Well, in this particular case, we can use 30 and 45 because we know that 30 and 45 make 75. So when we use these two, because again, these are nice angles, we know exact values for them. So our work would look as such. We'd say cosine of 30 plus 45. We know that the formula is cosine of 30, cosine 45, and again the sign switch minus 45 degrees here, sine of 30, sine of 45. Now, once we know that, then after that we can fill in the blanks here, because we know the cosine of 30 degrees is radical 3 over 2. We know the cosine of 45 is radical 2 over 2. Of course, they're next to each other, it means multiply. Sine of 30 is a half. Sine of 45 is radical 2 over 2. And then from there, if we do the math, we get radical 6 on top, 2 on the bottom. Radical 2 over, 4 on the bottom. And 2 times 2 is 4. And so a final answer here would be radical 6 minus radical 2 all over 4. So that would be the exact value of the cosine of 75, okay, without using the calculator. Now, are these the only two angles that would work? No. Okay, we could find two angles that could subtract possibly to give us 75, and then we could use the subtraction formula. Okay, the biggest difference here though is that we need to make sure we're going to use angles, okay, that we know the exact values for. So would it do us any good to write this as 40 and 35? No, because we don't know what 40 and 35's exact values are. So the only useful angles for us at this point are 30, 30, 60, 90, 45, and so on. Okay, all the ones that we know exact values for. Okay, I want to also look in your book on page 465. There's another problem I want to look at here. Okay. And that is just confirming an identity, okay, that we had from before. Okay, we had a cofunction identity that said that cosine of pi over 2 minus x is equal to sine x. Okay, we can now prove that with our formula that we just studied. Okay, it's a minus sign here, so we know it's cosine plus sine. Okay, so the left side of the equation we're manipulating as such. Cosine of pi over 2 we know is 0, so that whole thing right there would be 0. And then on this side we'd have 1 times sine x, which of course would be sine x. And so of course we'd have on the left side sine x, on the right side sine x, and hence we've proven, okay, with our new formula that this sentence that we had above is true. Okay. All right. Let's take a look at the sine equations. The sine equation looks as follows. Okay, the formulas are going to be sine u cosine v, okay, and then sine v cosine u. So sine of the first, cosine of the second, plus or minus sine of the second, cosine of the first. Okay, and in the case of the plus and minus part, okay, we notice that the sign does not switch in either case this time. So if it's sine of u plus v, then the sign on the right hand side is plus. If the negative sign in here, sine of u minus v, we would have these two expressions subtracted from each other. Okay, so sines are the same when we're dealing with sine. Sines are different when we deal with cosine. Okay. So here's an example of a different type of problem. We can do similar ones to what we did with cosine, of course, but let's take a look at this first. We want to know which of the following, write the following expression as the sine or cosine of an angle. And notice the key is an angle. We want to write this all as one angle. So notice that the first thing that we have here is that this is our u and this is our v. Okay, vu. Okay, it's got a plus sign, so that means it's going to be the sine of something plus something, and of course that plus is u and v. So the u and v, recognize again, are pi over 3 and pi over 4, and recognize that this is really just the same as that. Okay, this is going backwards, would be the sine of pi over 3 plus pi over 4. And of course from there we want to write it as the sine of one angle, so we're going to add those two together. If we get a common denominator with those two, we'd have a common denominator of 12. So we would have 4/12 and 3/12, and of course together 4/12 and 3/12 would make 7/12. Okay? So that would be an expression for the sine of 7 pi over 12. Okay, also want to look at on page 468, if you look at number 6 that's in the homework part. If we had to start with that 7 pi over 12, just like we ended with a minute ago, we already know that we know the answer is going to be pi over 3 cosine pi over 4 plus cosine pi over 3 sine pi over 4. Okay. And with that said, we can go ahead and fill in the blanks here. We know sine of pi over 3 is a half, or excuse me, radical 3 over 2, I should say. Cosine is radical 2 over 2. Cosine of pi over 3 is a half. Times radical 2 over 2. And so you'll notice that in this case we get the exact same answer as we got in the previous problem. We got radical 6 over 4, radical 2 over 4, which gives us radical 6 plus radical 2 all over 4. Okay. Now again, the key element here when figuring this out, we already knew it from the previous example, but we need to figure out what two angles, okay, would give us this. And if we're dealing with radians, it's going to be a little bit more difficult because we got to visualize the adding and subtracting part with the common denominator. Okay. So it might be smart for you to start out by writing the pi over 3 and pi over 4 and the pi over 6 as functions of 12, if you will, or as denominators of 12. So again, we know that this is 4 pi over 12. We know that this is 3 pi over 12. If we were dealing with pi over 6, that'd be 2 pi over 12. And again, some combination of those, okay, should work. Now, let's go ahead and carry on to the tangent formulas. Okay. Tangent formulas, you can do one of two things. You can either use the sine and cosine as we've already learned them, okay, or if you simplify, the simplified version is this. Okay, and if you look at the top of this, it's tangent u plus or minus tangent v. Okay, and then the bottom here, they have a bit of a typo here. This is supposed to be also a plus and minus. Okay, all right. Alright, and then from there, we can go ahead and do our work. Now, keep in mind that when we do the tangent formula here, when we have the plus sign, okay, alright, just like above, okay, since the top of this comes from the sine, okay, we know that the sine, okay, does not have a sign change, so we should have a plus. So if we rewrite this in terms of the individual u's and v's with a plus sign only, we'd have tangent u plus tangent v. And then the bottom comes from cosine, and we know cosine does have a sign change, so we would write 1 minus tangent u tangent v. Okay? And on the other hand, if it was u minus v, we would have tangent u minus tangent v. And the bottom would be 1 plus tangent u tangent v. Okay? So we'll use those in the same manner as we did with the sine and cosine. Okay. I do want to look at one more problem here. That's number 8 on page 468. We have the tangent of 11 pi over 12 we're asking for. So our first issue is, can we figure out what could we add to one another to get 11 pi over 12, or what could we subtract? Okay, we got essentially two options. Now, thinking of our nice angles, we know that 4 pi over 12 is a nice angle. We know that 3 pi over 12 is a nice angle. Okay, and we also know that 2 pi over 12 is a nice angle as well. Okay, All right. So if you look at these with the 4 pi over 2, if we look at what can we add to get 11 pi over 12, or subtract. As I mentioned earlier, we can make a subtraction as well. Okay. We're going to think of what could we add or subtract to get 11 out of all these numerators. Well, if we added these two, of course it's 7. Any combination of these two individuals is not going to get us up to 11. Okay. However, if we looked at what if we did 4, 4, and 12? Okay, think about that. If we did 4, 4, and 12, that'd be another way of saying 8, or 4, 4, and 3, I should say. If I did 8 and 3, those two would give us 11. Okay, so that's one way that we could build an 11 pi over 12. And keep in mind that if we simplified that, if I did 8 and 12, divided those both by 4, I'd have 2 and 3. So it'd be 2 pi over 3 plus pi over 4. Okay, and that right there would do it. So let's go ahead and calculate using our formula. Okay, from the previous slide. Tangent u, so tangent of 2 pi over 3 plus tangent pi over 4, and on the bottom we have 1 minus tangent 2 pi over 3 tangent pi over 4. So let's go ahead and do the math on that and see what we get. So tangent of 2 pi over 3, or if you don't have that in your head, you can make a unit circle. 2 pi over 3 is right here, and we know that tangent sine over cosine. Okay, the cosine here is going to be short. The sine is going to be long. So we'd have radical 3 over 2 over a half. So it would be negative radical 3 would be the value of tangent of 2 pi over 3. We know that radical 2 over 2 over radical 2 over 2, sine positive, cosine negative, is going to be our value for tangent of pi over 4, which we know that simpler to be as simply negative 1. Okay. And then on the bottom we're going to have 1 minus, and then when we multiply these two, we're going to have negative radical 3. Oops, that should be a plus, sorry. It's tangent of pi over 4 times 1. Okay, once again, tangent of pi over 4. And so we're going to get radical 3 plus 1. And then on the bottom we're going to get 1 plus radical 3. Okay. So that would be a valid answer for this situation. However, okay, we don't generally leave radicals on the bottom with numerical answers, so we would want to use our technique that we learned earlier, which is to multiply by the conjugate to get rid of that radical on the bottom. So the conjugate, of course, of 1 plus radical 3 is 1 minus radical 3. And let's go ahead and distribute on the top. We'd get negative radical 3. We'd get plus 3. We would get plus 1. And we get minus radical 3. And of course on the bottom, if we did the first and the last, we'd get 1 minus 3. We did the first and the last. And then simplifying the top, ultimately I'm going to put the answer over here. We'd get negative 2 radical 3 plus 4. And the bottom we'd get negative 2. And of course, since the number is out in front, all the coefficients are divisible by 2. Okay, we would reduce them all. I would also not have a negative on the bottom here. So I would multiply both top and bottom by negative 1 over negative 1. Okay, so not only reducing the 2, 2, and 4 into 1, 2, and 1, but also making the top negated and the bottom negated would give me a positive bottom. And on the top I would have positive radical 3 plus 2 all over 1. And so hence that would be my answer for the tangent of 11 pi over 2. Okay. So what we're going to be doing in this section is working with these identities to find exact values for otherwise angles that I would not normally know the right answers to in terms of exactness, and also dealing with some of the other issues that we've had dealing with identities as well.